This gadget is the USB-C cable tester, and as the name implies, it is there to test USB-C to USB-C cables, because USB-C offers a lot of features, but most of them are optional. And just by looking at the cable, you don't know which one is supported by the cable. And thanks to this tester, you can actually identify the supported capabilities. To use it, just plug both ends of the cable in the tester and read the lights. Here we know that this cable can be used to power the device, and it allows data transfer using USB 2. It is also shielded, so you can have high-speed USB 2 without problem. It is a higher quality cable. And it also says that the wire for the configuration channel is present. This allows, for example, power delivery to be used, so you can charge your phone or your laptop faster using higher voltages and higher currents. Now let's have a look at the next cable. One side and the other, and this is almost the same. There is an additional LED, the E marker LED. This means that this cable is electronically marked. There is a chip inside which actually tells a bit more about the capabilities of the cable. The tester doesn't read it out, it just identified that there is a chip inside. And if you would read the chip, you would see that this cable can be used for up to 100 watt charging. The E marker is a strong indication of the 100 watt, but it's not a must. It just tells that this is an electronically marked cable. Now let's have a look at the last cable. Up. One side, the other side, and we see all the lights are on. This is what we call a full feature cable. Additionally to the previous cable, the super speed LED is on. This means that there are differential lines which are used for USB 3 super speed. So if you want super speed data transfer, but they can also be used for DisplayPort, HDMI, and so on. And then the last LED is the sideband use. This is for USB-C accessories, audio, and things like that. More that can be supported by USB-C. And although the E marker is there, if you read out the chip in the cable, you'll see that this is only supporting 60 watts and not 100 watts. But at least we've identified the capabilities of this cable using the USB-C cable tester. Now let's have a look at all the versions. This is my very first prototype, and this is rather a proof of concept. I used USB-C breakout boards and a lot of wires and some transistors on the back to actually have a proof of concept and see how to implement the tester. This is version 0. It is still a prototype, but it works. This is version 1, the first production board. We have one less SPU LEDs, it looks nicer, and it is ready to be used. This is version 2. It's very similar to version 1. It's just that the markings are a bit bigger, the connectors are a bit different, which is more reliable to produce, and if you want more information, you can always look at the back. You will see the version number, and the QR code will point to the website and the product page, where you can find more information about it. This is the schematic for the USB-C cable tester, and it shows you how it logically works. Basically, I just verify if the wires are present in the cable by letting a bit of power through, and if the wire is present, then the LED will go on. For example, here we start with the battery. It provides power on VCC. Here on VCC, on one side of the USB, so on one of the USB receptacle, it goes through V-bus, and this should go through the wire to the other receptacle. And then it lands on V-bus, it goes through D1, the power LED, then back to the ground and through the wire of the cable, again to this ground, and it is grounded to the circuit. So if both wires are present, the V-bus and the ground wire are present, then the power LED lights on. The same is used for the USB LED, for the super speed LED, which actually has 4 pairs. Then we have SPU, which is 1 pair. And for the CC wire, which are used for power delivery, we have 2 LEDs. This is because there's only 1 wire, but depending on the orientation of the cable in the receptacle, it is connected either to CC1 or to CC2. But the more complex part is detecting the E marker. When the cable is electronically marked on the CC line, which is either on CC1 or CC2, there is a 1 kilo ohm resistor. This forms a voltage divider with the 2.2 kilo ohm resistor, and this enables this transistor, this one or this transistor, so that the E-marker LED goes on. And because this is open source hardware, you can find all the schematics, the board layout, the source files, and more documentation for all versions on the CuVoodoo website. And to test the USB-C cable tester before I ship them, I built this aperture, where you can just insert it and all LEDs should be on. Well, here we only have 1 or 2 because it depends on the orientation. If I now turn the tester and plug it in, we see the second LED is on. And this board is ready to be shipped.